Okay, thank you everyone for coming along. As Stacey said, I'm really here to present today the awareness of cybersecurity around the Intelligent Building Management System. I'm not going to send you home hackers. It's really just to try and raise your awareness of some of the important subjects around cybersecurity. So if we look at in more detail the agenda for the presentation, is to really set the scene around the Intelligent Building Management System and why that plays an important role. Look at the IP convergence and how that's bringing benefits to that built environment. And then look at what that means in terms of how that's potentially introducing threats into the building. Look at cybersecurity and what that really means and how it helps to protect you from cybercrime. And then looking at some security management methodology as to how that could be an ongoing process to protect you. So the Intelligent Building Management System of today really is focused around some key drivers. Primarily there's obviously energy efficiency, energy costs are rising, and really government's regulations and legislation requires us to have an intelligent building management system. The level of integration with the subsystems that we see in a building is on the increase. They're becoming ever more complex. I mean, you can see on the right hand side really just an overview of some of the systems that are connected. And really they're being interconnected over an IP network. So a lot of the protocols that we now see in building management technologies run at an IP level. Looking at the next slide, we can see really what an IP converged system actually looks like. So many different subsystems connected. In terms of on an IP network, you may be carrying building management systems, a primary focus, so building management, HVAC, climate control and monitoring, energy metering, power supplies, lighting control. Your security systems will sit on the IP network too, so there'll be video surveillance, access control, fire, life safety systems, identity, communications as well, business systems, so we're connected to finance, reporting data and observing data from systems like SAP, and booking systems, hotels use room booking systems that integrate with the building management for optimization. So there's a wide kind of range of systems that all kind of sit together on the IP conversion network. And the reason for that convergence, as well as the technology drivers, is to reduce capital expenditure. So by having this sort of consolidated system on an IP network, we can lower equipment and software and engineering and installation costs. We can get a common footprint, so your devices are installed on a network that is common and is understood within that building. And to utilise technologies as well, sort of power over Ethernet, so it gives you that flexibility of moving devices around, not having to fit power supplies locally, and being able to be more flexible. Lowering your operational costs as well, meaning that you can really train your people faster. So if we have one intelligent building management system that connects these subsystems together, it's easy to get people trained into that one system environment so they don't have to learn multiple systems. That also means that you could potentially have less staff looking after your overall system. You can obviously maximise your energy reductions with a system like this, and minimise your maintenance costs. You may not need maintenance contracts with lots of different providers if this is all connected back to one single front-end system. And of course, with all that becomes some simplicity in the system design as well. So standard processes, one system to learn, we talked about that. We can get information to people at the right time based on their roles and responsibilities. So having connected all this information together, we can bring more meaning to that and share that with others. So within that integrated control platform, threats are very real, and they can be very deliberate. You know, we can talk about terrorism or cybercrime. There are a number of different reasons why threats may be deliberate. It could be an employee that's unhappy or has left, and dare I say, it could be a competitor. It can be very unintentional. Introducing a threat into a network is not necessarily something that's done on purpose. One good example that I can use really is as a way that it might explain it well, and it comes into one of the further slides, is maybe when was the last time you found a USB stick lying around and you thought, oh, I wonder whose this is. You know, you might have been innocently wanted to return it to its owner, find out if there's anything on there to tell you who it was to return to, or maybe you were just thinking, that's a nice large stick, I'll have that. So you plug it in, and you don't think much of it. But if you were targeted for an attack, That could have been very specifically intentionally left in your building, in your facility, somewhere that you were likely to go and take that and plug it into your network. And without really thinking, quite innocently, you've introduced an issue. You've put a virus onto your network. And of course, these attacks therefore can happen within your network and from outside of the network. These can be remote, talking about an intelligent building management system, often connected to the cloud. We talk a lot about Internet of Things and connecting devices together. So making your system connectable to the web, to external sources, also makes the ability that those external sources can be used to come into the network as well. And when we think about the effects of an attack on a network, loss of control. There's a good example, a documented case of a really sort of high-profile luxury hotel where a guy was in a room. He'd been given an iPad, an IP address to go to control his room control. He could control his lights, his ventilation, probably a few other things in his room. And he happened to just notice there's a bit of a correlation here between my IP address and my room number and the floor. So he was a smart guy and he just put a different one in. Oh, I've got somebody else's room, I can turn their lights and blinds in. And really it's a simple case, but in many respects, not having any connection and security and authorization around that, just leaving that open, it's loss of control. And if you thought about that maybe in a healthcare, in a hospital environment, if that was a patient room, if that was an operating theatre, and somebody was playing and having a bit of fun, that's not fun anymore. It can obviously cause loss of visibility as well. So, you know, with an attack within your network, with a problem that's visible, it reduces your visibility, so you can't see what's happening, and again can really lead to operational risks. A good example of another one there is the Stuxnet virus, which happened previously with a PLC system, and that was an attack that was used to falsify information reported back to the central control system. So to an operator, they thought everything was fine, but actually within that PLC network, actively, this was destroying equipment and taking down an operation. And that's another sort of well-documented case of a virus attack within a network. And of course, it can lead to a loss of data. So if you think about data loss, again, another use case I can give you would be a major retailer in the United States. They were attacked through a innocent broadband connection used for remote services and support to their site, and an attacker was able to connect to the network. The building management system wasn't actually part of the attack, it was just the entry point. They got hold of about 40 million customer records, payment details, credit card information. They were able to get into the network that was converged onto the building management and operational layers of the IT layers of the building connected together, and that led to a massive loss in personal data. So of course, there's disruptions to building systems, disruptions to security systems, and your business systems. Everything really can be at risk. So, if we really take this thought about a building being compromised or insecure, and think about where we look to the future, you know, we might have heard and talked about smart cities, smart grids, smart homes, public services and mobility all being connected. So if that's a vulnerability that can happen in one building, then it's quite possible that those same things connected in the same way can extend to a much broader sort of scenario. So taking a building that's connected to infrastructure and those viruses potentially passing between them, it really offers a threat. We look at infrastructure and we look at a smart city or even a smart grid, where maybe previous proprietary protocols are now being moved towards more open protocols. You might think about Modbus control type devices that will sit on a network, and inherently those protocols aren't secure, so you have to think about physical network security. There's lots of things that can actually be a concern in that type of environment, so it really takes a good policy on security to understand how that works. If we looked at how somebody might try and think about connecting to you or breaking into a network, there are actually many ways, and this is just a few for discussion here. People, for me, is really the absolute biggest threat to security. It doesn't really matter what you do with the other side. You can have the best infrastructure systems in place to protect your network, but it's the people that are the biggest threat. I mean, I talked about the innocence of a USB stick, and that's people really. You know, it's the methodology of getting that to you is a USB, but that was someone taking a memory stick and plugging it in. So there are a number of ways. Pretexting is a way of presenting yourself to someone as an attacker presenting themselves in order to obtain private information. So it's an attacker's creating an identity to try and build a scenario where they may be able to get information from you. There's terms known as phishing, it's spear phishing. You'll be familiar with probably sort of a phishing term. You're seeing it probably a lot on your PCs pop up, and when you get emails you can report them. And that's an approach where people take to gain valuable information. So the example you can probably see illustrated there is, you know, you've got an email from your bank and they want to know your password before they talk to you. And that's a kind of phishing approach where they will try and gain some trust in you by presenting themselves as a valuable, creditable organisation that you may or may not have any relationship with, and try and use that to gain information from you. The spear phishing approach is actually a bit more targeted, it's a bit more sinister. They try and get more of a relationship with you and understand more about you, profile you personally a bit more, to try and build a much more trustworthy scenario where you are more likely to let your defences drop and give them that kind of information that they're after. There's technology approaches. Wi-Fi is a good example. There are devices that, you know, when you're out and about and you're next in a McDonald's or a Starbucks or you're somewhere and you think you're innocently connecting to a free open Wi-Fi, are you really connecting to the Wi-Fi that company produced, that they made available? Or has someone wandered in, you know, with a relay type device that can actually present itself as that wireless hotspot? So you connect through a middle device, and that's then able to potentially track insecure communications that you might be making. So, you know, would I want to go and do online banking somewhere that I didn't trust a connection with? Maybe not. It's about making sure that you really trust the point that you're connecting to and can be fairly safe and secure in understanding what might be in between that. Public places are obviously a prime target for these types of things. They're used in hotels a lot as well. When you think you're connecting to the hotel Wi-Fi, you may not actually be, or you'll be going through a leak between it. They can obviously exist on Ethernet as well, so providing sort of a stealth remote access and network intelligence gathering and sort of man-in-the-middle surveillance. So they'll be targeting a way of trying to intercept data and look at things that are going over the internal networks. And we talked about USB, or even a USB device that might pretend to be like a keyboard login type device, so it can detect keystrokes and information that you're entering into the computer. And then operationally as well, of course the biggest weakness with many systems is passwords and password vulnerabilities. How many passwords do you have to have for various systems today? The requirement for them to be more complex is because the data that's held is of value and you know, is not something that you want to let go easily. But of course, creating complex passwords means you might start to write them down somewhere, and then is that a problem? And it's, you know, it's managing passwords and understanding that passwords need to be complex, and you need to think about using, you know, characters that are not just alphanumeric, you know, throwing in some exclamation marks or whatever it would be as well. So passwords can easily be broken using sort of rainbow tables and different attacking methods. So it's really a good, you know, an easy way to enter a system is through vulnerable passwords. If you leave default passwords in systems, that's clearly not a good idea. Impersonation attacks as well, really just by somebody pretending to be someone else. So a scenario based on what we talked about previously, how a virus could cripple a nation. So the virus gets placed onto a USB drive, and that USB drive's plugged into a computer. So we're now into a secure network that we thought was secure. So it starts to scan the network, it learns a little bit about it, creates a blueprint, sends it off-site to an external server. Someone can use that information to engineer a targeted virus to come back to specific computers within that network. It can then subvert software controlling specific items of plant or machinery, and computers on that network. And as we talked about with the Stuxnet type virus, it can send false messages back to the system, to the operators. Hey, I'm fine, everything's going fine here. No alarms, no problems, fans are still running. But really, it's actually set into a destroy mode, so it's overrunning things, it's killing things, it's stopping things from operating. And if that scenario we talked about, from a building to a grid to an infrastructure, a city, that virus could spread. That could then spread through a much more wider connected network. Critical infrastructure could be compromised, and that could be regionally or nationally. It may sound dramatic, but with the connected networks and things connected together, without secure policies in place, this is a very real possibility. So, if you saw a USB stick lying around, what would you do? The cost of cyber attacks really varies by country. Cybersecurity breaches cost billions each year. The damage to your brand can really be incalculable. We can see there that the sort of cost breakdown of a cyber attack, and we see that reputation plays a really big part in that. But it's the brand piece that I think is the one that you just can't put a number to. It's what it does to you as a business. It's what it does to the vendor, the people that provide that, if an attack was to happen. Obviously, the largest is damaged reputation, and obviously there's a big loss in productivity and revenue as well. So systems taken down, infrastructure taken down, can really have a big impact on an operation. So we talk about cybersecurity, and it's really now recognised as a body of technologies, processes and practices designed to protect systems. It's important because it strives to minimise your business interruption, maximise your operational integrity, making sure that people and your processes and your assets are all working together securely, minimising your production downtime, and protecting your intellectual property, so making sure that private data remains private. And of course, to make sure that you're compliant with your international and national regulations. So we look at cybersecurity throughout the entire life cycle of an IBMS system. It's critical at every stage. From the design perspective, where we establish cybersecurity and resilience requirements of the buildings and its systems and devices, through an installation phase, where we manage the supply chain, making sure that the install of the IBMS is not vulnerable. It is very vulnerable to attack at this point. There's a lot of people coming through, there's a lot of contractors working on site. You don't necessarily know who's what, who's where, so monitoring the design integrity is very critical because a lot of new things are being introduced onto the network. And then through the operational phase, it's about making sure that you proactively manage and identify your risks, follow an ISO methodology to actually plan and check, and really building an awareness program within your organisation so that people are aware of the risks and the right things to be doing around cybersecurity. So to look at that in a little more detail, in the design phase, we'd look at physical security. So your physical security prevents unauthorised access to devices, networks, and the information that you have in that building. You need to really consider the access to the buildings or the rooms or even the cabinet levels where routers, firewalls and switches are located, and locate critical devices in secure locations, locked cabinets, and make sure that you protect cable runs with rugged conduit. And then looking at the network infrastructure to limit your network access, and make sure that everything is secure, so you don't want to expose lots of points of entry to your system. Think about making sure your wireless networks are secured, making sure that you don't have network ports all over the place where anyone can just kind of connect into it. Comes back to the physical security element as well. Are people in places where they can access the network? And really utilise firewalls to control the flow of information between segments of your network. And then the people side of it, managing user access, making sure that you restrict access, using centralised stores, in terms of Schneider's building management platform, we integrate with Active Directory. So that's a good policy to use, is to leverage that so that you get, when new starters start, they get access to the system. When they leave, access is taken away. That can enforce complex password policies that need passwords changing every 30 days, 60 days, 90 days, whatever you might choose. And make sure that you restrict your connections. So if it's a connection from outside, make it secure. Use VPN, use secure protocols, use HTTPS. And utilise the DMZ approach, or the DMZ if you're American, to make sure that you keep your services that have to be externally visible separate from your internal services, and only very restricted data channels are allowed. So a DMZ approach is illustrated here, with firewalls as well. So within an architecture like this, you may have your building management system in the green box below. A firewall would prevent and manage traffic between a public service access service and your enterprise server sitting at an enterprise level. So it's about utilising firewalls to create segments of your network that are more secure than others because they may be more exposed. When we look at the install phase, it's important to look at hardening your system devices. So using that sort of situation around USB memory sticks or CD-ROMs, remove them. If they're not needed on BMS workstation terminals, don't even have them. Don't allow somebody to connect devices that they shouldn't be able to connect. Certainly make sure that your workstation software, your operating systems have good antivirus technologies. Make sure that they're from reputable providers. Make sure that your operating systems are getting updates and you enable all the security features that you can. Configure your user accounts for access. Make sure that you don't have those default passwords that everybody knows that if you go onto the internet and search what's the default password for this device, you know it. Disable by default. So when you give somebody access to the system, don't just say, you're an engineer, you get this level of access. Disable it by default. Find out what they need to access and why, and build their management policy up from that level. So understand the use case of the users and really make sure that you're not enabling or letting them do things they shouldn't do. Use expiration dates on your passwords and force your password changes. And there are software solutions and devices which come under the sort of hat of threat detection and mitigation. So you can monitor your network's devices and activity, and monitor physical and user activity. So it's possible to sort of profile a network and understand what is normal for that network, what devices talk to each other, what protocols they use, and then have alerts raised if another device just comes onto my network and starts talking Modbus to these devices that always used to talk to each other but nothing else used to. So why has somebody just started talking to my devices on Modbus? And it might be innocent, it might be a controlled install, but at least you've been alerted and you're aware that something's come along, it's entered the network and it's started to do something. So there are software solutions, and hardware solutions around that can help you in that. And then through the operational phase, continuously monitor. Again, using those analysis tools, monitor your system, report incidents as they happen. And build a security awareness program within your organisation. So again, have policies in place, have procedures in place to manage your accounts, use trusted sources. When you want to go and get the latest update for your building management system, get it from the manufacturer or from a reputable partner. Don't go downloading it off of the web from a site that's just posted an update that you didn't trust. A lot of people will use digital signatures with their software so you can validate the authenticity of where it comes from. And really develop a plan and method statements for installing hardware and software, and make sure you have good backup and recovery procedures in place, because if something does happen, it's going to be important to get yourself back to operating as fast as possible. And perform some security audits. So, providing a means to make sure that your systems, policies and procedures are effective and don't have gaps. Report breaches if they happen. Any attempts to acquire passwords or people not following procedure. And really, an effective audit assists in the ongoing improvement phase, because I think with cybersecurity, one thing's for sure is you can never be safe. We were asked by a customer recently, how can you guarantee that my system's secure? I can't. There's too many factors, and there's too many new threats coming out all the time. You just have to have processes in place that means that you're checking, you're monitoring, and you're always trying to make sure that you're as up to date and current as possible. So if we look at that in a security management methodology, really a plan, do, check, act approach is the best way to try and manage this, to say, because cyber attacks, they happen all the time, and you really can't be sure that you're ever 100% secure. Plan would be to carry out risk analysis and develop your security measures and create those policies and procedures. To do is the implementation and the carrying out of those training and awareness programs that you might have around cybersecurity. Checking, so monitoring and detecting incidents, making sure that the things that you have are effective and compliant. Because as I say, it's like your antivirus programs, they want to update all the time, new threats are happening, you need to make sure that they maintain up to date. And then act, take the corrective and preventative actions as you do them, based upon the information and the results that you've obtained in this process, and that cycle has to go on. So that really brings me to the summary for this cybersecurity presentation. As we've seen, really the point of this presentation was because buildings are becoming more interconnected, becoming more complex. Cybercrime is increasing, and it's the fastest growing crime sector and costs companies billions a year. Cybersecurity requires an ongoing, continual, proactive approach throughout the entire life cycle of the building. So what does Schneider do? We have a dedicated team of cybersecurity experts. They are building an awareness program and release information about security threats and vulnerabilities. They obviously take into our systems and approaches to manage those threats as well. But I think if anybody wanted any sort of further reading, there are some excellent white papers on our cybersecurity pages at Schneider Electric. And really they are there to best advise you on some of the different approaches to securing your networks. I have a couple here sort of in printouts. We have one on network intrusion detection systems for critical infrastructures, and really a very good one here which will go into far more detail than I have today, is how to defend against a cyber attack for building management systems specifically.
They're on the website.
They're all publicly on our cybersecurity page. So if you go to schneiderelectric.com, across the toolbar at the top there's a support tab, and within there you'll find cybersecurity, and that is where all the white papers are listed. It's where our vulnerabilities are announced, so if we detect a vulnerability in a product, and that spans Schneider's entire product portfolio through PLCs, power, everything that we do. All vulnerabilities as they are found, they're listed there. I think you can connect into an RSS feed so you can actually get alerts. And we're in the process of setting up a platform where obviously you can understand probably that in a cybersecurity world some of this information is also quite sensitive as well. We wouldn't want to openly publish what might be security flaws, because we'll fix them, but whilst we're fixing them we don't want people to know that that's an easy way to get in. If they find out, they find out, but let's not tell them about it. So we have a platform that we're building, which is like an early announcement system, but that requires a non-disclosure agreement with the customers to make sure that, again, we kind of have an agreement that we'll share more with you about our cybersecurity issues, because as I say, they are ongoing, and really that gives you an insight to being more connected to us in that way. But yeah, that's really the end of that presentation. I'd happily welcome any questions if I can answer. I will.
The second slide you've got cheaper, I think it's cheaper capex. Is that correct? I thought it was higher capex.
From a...
The second slide.
Let me come back to
There.
this one here. So lower capex. From a Converge network.
Well, in general.
So this slide we're talking about IP convergence and why, if we were setting the scene, where this comes from. So having a converged network, which means connecting building management, energy, visitor management, intercoms, lighting, biometrics, videos, elevators, access control, all of that back to a common front end. The reduction in capital expenditure is less equipment. If you are integrating all of these subsystems, you don't necessarily need to have front-end management software for each. You don't have the installation costs that go with them all because you're not going to multiple vendors for different total solutions. It's one intelligent building management system connected to smaller subsystems. They sit on a common footprint, so you may not be running a network in for one, a network in for another, a network in something else. They're all connected on a common network. So I think that's where the discussion around reduction in capex comes from, a converged, multi-faceted building management system. So it was really used in this presentation to set the scene for how we get to what can be a big threat to a building management system today from the fact that all of these technologies are together on that IP network. So yeah, I think, Stacey, would you have anything to add to why we would say a reduced capex? I think the numbers to back that up.
What you were saying there, if it's managed properly as part of from the outset as part of the design solution, and the IT network companies engage with the IBMS company, because they're not necessarily all from the same vendor, but it's how you then manage that convergence onto the network. And so, yeah, like Gareth was saying, you don't need to have multiple software platforms.
A common network is a risk in itself, though, isn't it? Because what you've done is you've taken away the resilience by putting all of those systems onto a single network. So you've created a single point of failure, arguably.
Probably not. I could argue that within an IP network, you could actually have a much more resilient network if that was built with redundancy within it. Then, as an IP network, that's far more resilient than necessarily what may have been previously, a serial communication network down to a device. You can have, multiple routes, diverse routes of IP networks within a building that actually, on the whole, would give you more resilience. But yeah, you are putting all your eggs into an IP basket, but an IP as a technology would allow you to have quite a resilient infrastructure in place.
And still give you a reduced capex even with that level of diverse routing resilience built in with it.
And that would be part of what would be considered in the building phase. So not necessarily a reduction in capex if that wasn't planned for and you thought of that, but it may be that we're talking about, it's a lot of, it's a buzzword you hear a lot of, it's the IT OT thing and how they come together. So really we're talking about putting operational technology onto the IT network that's probably already there, and we may just have to talk about bandwidth and sizing to cope with some of these extra demands. But you're trying to leverage an infrastructure that is already there in the building, so it would be likely that they would already have that kind of infrastructure.
It's about, I think one of the things that this cybersecurity covers off is people are going, the way the industry is going is away from just thinking about BMS or controls as controls. It's about data, and about big data, managing that data, what you actually do with it and where you want it to go. And that's where these IT converged networks really come in, because you can take all that information out of the lighting system and put it onto one or two.
It's the value of bringing all of that data together and the value that you can bring by overlaying.
You could still have that on a separate network.
Yeah, absolutely.
IP network to the IT. So what I'm going to ask is it right to have a converged IT network with a smart building network? Or is it safe and more resilient from a cyber perspective to have separate networks?
I suppose there's probably different ways of looking at it. I would think from a security perspective, you would say if you are totally segregated, completely managed separately, you don't have the risk of being on the same network as maybe some of your buildings, your IT systems. Would you perhaps be as likely to manage that as well? You know, would the IT own that, or would that be seen as an operations person's responsibility? Oh yeah, that's the building management guys, they look after that network. And would you have the same rules, policies and procedures around that infrastructure? You might lose the value of some of the other connections that you can make in and around that building. When we talk about sitting on a single network, actually from a security perspective, you very much would want, and that's one of the things that we touched on a little bit, is having firewalls and segmentation. You'd run separate VLANs, so you would allow data to pass at specific points, but it wouldn't just be there's the file and print server for the building, there's the SAP server, and there's my building management controller, all connected on the same network, talking to each other openly. There would still be within that network levels of segregation.
I think the argument there's different arguments that you have in all the things that Alex has just said there. Absolutely. Then there's a counter argument to say, however, if you went operationally want to use that system, every time you want to make a change to it, you have to go to IT department, you have to get all that. But that actually highlights the point, because if you've got your computer sat in a security suite somewhere that anyone can gain access to, anyone can hack into, and like Alex is demonstrating there, if I can get into there, I can get to anywhere near it once I've released that virus into that system. So it should be sat in, and it should be protected, it should be managed by the IT services. And yes, it's a bit of a pain in the backside if later you've got to go and load something, because you have to adhere to and follow all the procedures around that security.
But they were there for a reason.
But they're there for a reason. And a lot of people don't like doing that, and they don't do that because they don't see it as a threat.
You got involved with the insurance companies to relay that premium, like giving them confidence to either broken the network down, or have we been forced by any issues like the financial sector that has to be independent of the firewall system?
No, I don't think we've seen that at all. I think we've done the converged network approach in all sectors. I think it's quite common. So no, and certainly from a risk management, it is very much around setting up the right network security and having sort of not separate networks, but segregated networks, using VLANs and allowing data to pass at strategic points between specific devices. But no, we've not, I certainly have experience of being involved in looking at utilising this type of approach and cybersecurity in general to reduce any as I say, because I think the biggest argument is you can't, I would never say to anybody, I was asked by a customer, how can you guarantee that this is secure? I can't and I won't, because tomorrow, if it was secure today, it might not be tomorrow. And you've got people in your organisation that can obviously throw something else into the mix as well. So it's a very difficult subject, and it needs a lot of things to come together through policies, procedures, practices, the right systems, the architectures. Everything has to come together in harmony, but it's about doing the best you can.
And usually systems, you say, cover all sectors, so government, Ministry of Defence, Ministry of Justice, all those sorts of places you use, not IP convergence and like that.
Yeah, I say hospitals, healthcare, this is quite a common.
There's some really big security requirements associated with those.
Yes, I mean, I know that, yeah, I was going to say, I know structureware as an application is being used in the US defence sector as well, so they've approved the structureware platform for use in their military organisation as well.
The key around this that Converge network and around that makes it work. I had this discussion with someone last year in London, saying it doesn't work. It doesn't work as single network infrastructure. It doesn't work. It's all about the design and the management and the thinking, how you implement it. You know, having your IT infrastructure company go off doing their own thing, without having steering groups, without having the engagement with the IBM supplier around how it's going to work, and all the other suppliers who we're engaging with. And we had a couple of nights we were discussing earlier about, you know, all of the lines of engagement to the different systems and what their levels of protection are. You know, because if we're talking about IBM, there are there's fire alarms, there's lighting, there's all these other systems that are connected to that network. What have you asked the question, what have they got in place to stop people coming in through their system?
Do you not find that companies though, that because they work in isolation from one another, they like it that way. And the biggest resistance you're going to probably have is people. Because people want that isolation, they want this. I think Birmingham Airport, we had the CCTV, the special branch had theirs, and then they had 6 cameras, and I said, look, we have one system for all the cameras. Your 6 cameras will go back and divert back to where you were looking at. But they had 3 cameras in a line. One was special branch, one was the police, one was the airport. And wherever this one looked at, the others just followed what he was looking at. And I said, it's crazy, but they said, no, they said, we want it separate. Our 6 cameras are separate. And that's the biggest issue we've got with people and convincing people. And especially when you're saying about standards and that sort of thing, because nobody wants to spend the time doing it.
Yeah, I think a lot of it sits around the value proposition you can put to what it is to have these systems converged, and it's everything around the bottom box in the centre there. It's having a single pane of glass. It's being able to see what's going on, having all of that connected together, driving cause and effect. So if there's a fire alarm, being able to interact with the security system, being able to interact with other video surveillance, access control. You may unlock doors, you might switch cameras on. There's lots of things where cause and effect behaviours that are driven through this level of integration. They're the real drivers, and actually a lot of those requirements will come from the customer. But it's the value that you have as well as a data platform, as an aggregator of all of that data that you bring together. You can provide reports and insights into your building.
I mean, we're seeing a lot more now around, you talked about people. People are your biggest expense and your people asset, your biggest asset for your company. And a lot more organisations now are looking at how they connect people, how they connect their people together through workplace efficiency. People are creating areas where they're going to come together, and some of that's to do with where they're moving into the building, where the hotspots are, and that's a whole new area of whole building design, I think, is the
So we touched on this building analytics. It's all that big data. So these standardized systems aren't going to be there for the next 10 years' time. It will be converged, there's no doubt about it. It's that data, it's that information, being able to use that information strongly.
Well, they clearances as well, like there's certain people can look at CCTV and they're not cleared to, they've got a certain level of clearance. Other people, and I know you said it's segregated on.
Yeah, and within that, there's management of permissions, So if I'm an operator and like you say, there's separate roles, but that's what you have within your system. You build those roles and responsibilities and give access to the people. You get the right information to the right people at the right time, on-site, off-site. It's all connected. You're able to provide that sort of service.
I think the government putting more processes and procedures in place to what extent, because it's that new British standard 27,000. So the MOD and the government are going along that line, so that your company are following a process and procedure to try and overcome that. Because there's so many avenues that you can get in through the back door, but it is about what you said around processes and procedures.
Yeah, I mean, we follow a secure development lifecycle program in Schneider, so that's documented in one of these white papers as well, around how everybody's trained and understood. We have a bunch of e-learning courses internally within Schneider that people can go on, and again, they're probably more targeted even against people, because I was saying people are just such a big risk. You don't think there's a USB, I'll just plug it in and find out. You might not want to rob it. You might want to find out who it belongs to, and you're totally innocent in what you're doing, but if your building, you personally have been targeted for that, it's such an easy thing to do, and password policies and all the rest. It's just educating people and having the policies, like you say, and the processes in place to manage it all properly.
So you used an interesting word there. So your back-end slides talked about design, install, and operate, and you just also used the word lifecycle there. So let's dwell on the renewal and the refurbishment and the component replacement aspect of single BMS systems, but I guess importantly, converged systems where you could have anything up to 10, say 15 different manufacturers all linking into the common platform. So how the hell do you keep on top of IT security when you've got 10 or 15 different products or product ranges, all with different life cycles and different components being replaced and upgraded through the life of the system, and trying to understand then the consequential impact and dependency between all those things and how they work together, and what potential threats and vulnerabilities that might create to the system as a whole.
Yeah, it's a good question, and it's only one that you can manage with planning. It's having those processes in place. You know, we touched on it, I think, in the sort of the planning section as well, when we looked at where were we? So having policies, procedures, management accounts. I'm sure I had it somewhere. But yeah, it's how you're going to manage that. Have plans in place for that. But that's all you can do. Is plan for it, have processes in place, and understand the risks, and follow that continuous cycle of planning and checking. So there's tools that you can have that will monitor your system for current threats. So you can do penetration testing on your network, find out where your weaknesses are. But yeah, through the lifecycle of different products, you'll find that if you've got one system that runs on a particular version of Windows, that's what you have to build into your policy. Is this system may need upgrading before the technology is expired. As a piece of hardware, that might still be a very valid piece of hardware. What are the security risks if the operating system it runs on isn't secure? And it may be that you just implement secure. There are ways of making that particular server, that piece of software, live for a bit longer. You can implement some technology on there, whitelist and blacklisting technologies that can really harden that device much stronger than you might normally. But that would be through identifying that, yes, it is a weakness, so I'm going to put something in place to extend the life of that. So yeah, it's very difficult, but something you'd have to manage through planning.
And also looking at actually looking at what you're actually utilising. I mean, we've seen things recently where people using XP as an operating platform.
What's wrong with that? What's wrong with that?
There's a few things that are wrong with that. But that's an example. And if you weren't aware of that, that's massively open to attack. But
And that's it, and so there are things you could do on that to give it a bit more life, but you have to absolutely build that into a strategy to identify that is a risk. As long as you understand the risk, you can do something to manage it.
I suppose it's also endorsement actually of the one Converge network, because you will have your IT team that will take control of that. And that's what they're doing for a living at the moment, allegedly. A lot of things in our place. So updating the software, allowing you to
the issue may come with compatibility, and I don't know if that was one of your questions.
Well, yeah, it's not all about software, I think. It's also about, some of the older components 10, 15 years ago in some of the older BMS systems, they did the job that they needed to do at the time. Mm-hmm. The upgrade path now is the thing that we buy from you now does that job and 20 other things that we don't want it to do, but we have no choice. So that little box that we put in now, my God, look, it comes with Wi-Fi, it's got Bluetooth, it's got all of these things that we never had before, which introduce additional risks that may not have even been on our initial risk register. And there's a white paper on it. Excellent.
There is a good document.
But it's that sort of thing.
I was prepared.
It's that sort of thing that worries me, because
yes.
It's not just about the software. I guess that's the easy bit. That's about understanding what it does. It's about the licensing and how that works together. Mm-hmm. My concern is the building blocks that we're forced to put back in, because technology has just moved so fast. Yeah. And we have no choice, because you don't offer that basic product anymore, because your business model doesn't cater for that. Your business model is about developing, progressing and market leading.
So that's where this IT planning guide is very useful actually. It's an excellent document that's been released, again through our cybersecurity team, and this will talk about structureware, building operation, workstations, enterprise servers, automation servers, how those devices connect. It tells you every single protocol, communication path, ports that are used. It helps you plan your network design. It helps you understand what you should turn off if you're not using it and what you should turn on. So there's a really good document there, and that you'll see if you look at this at any point in time, you'll see at every single item that they talk about, they'll talk about the version that was implemented. So you'll see it's just a continual process, even through the life of structureware, which we think is a really modern and up-to-date platform. It is. But you know, through the life that it's had, the very short life it's had already, the cybersecurity enhancements that we've seen are huge. And I guess that's the point. Is it's just that planning piece again. It's understanding, and I suppose one thing you may talk about there, and it is a piece that you have to understand when we talk about structureware as a product. Yeah, it's really secure. It's dead good. Look at this. You can see here. There's loads of stuff that it does, but it also talks Modbus. It talks BATnet. It talks LOM. It talks web services. Well, Modbus, BATnet, and LOM are old protocols. They aren't built with any authentication or authorization. There's no security. By their definition, they're open protocols. So if you don't manage your network security properly, you don't profile, and you say you don't think about, I only want this device to talk to this device, and I want it to talk to this device. That's the kind of procedures you have to put in place, because otherwise I can just drop a new BATnet operator workstation on your network. I can go and discover what's there, and depending on what that device supports, I can start to exert some control. So you have to be very, very careful when you're thinking about open protocols. It's the solution. This piece of software is great. Lockdown, you won't break into that. But it might be just as easy to come along and just be like that workstation on the network. Because if we were talking to a BATnet site and that wasn't set up with any network security, forget that. I'll just come and control what I want anyway because it's an open protocol.
BATnet over.
Yeah. So that may have been one of the things as well, introducing things that you now get an automation server that talks all these wonderful protocols that you wouldn't have bothered about before because it never did it. So it's understanding what those are, and that's really all we're trying to get out of today is to raise a bit of awareness. I'm not going to send you home a hacker today. That's unfortunately too much to cover. But if I could at least leave you with some thoughts about security, some of the risks, and point you in the direction of some further reading and learning, then that'll be a good thing.
Yeah, I think, like I say, technology is moving on at such a pace. Obviously we said this a few weeks ago. 20 years ago, we didn't have mobile phones. We didn't have smartphones. We didn't have all of these things. Now I walked in to buy a new television 2 weeks ago, and I left the shop without the television because I had to go home and do some research on what the hell I was actually wanting to actually even buy, because there's so much variety, there's so many different things. I was confused. Back in the day, you'd walk in and go, I want that box, thank you.
And I think that's it. It is that thing, and it's making people understand, particularly on a Converge network. It's difficult sometimes for people to think, oh, it's just a building management system. It controls the boilers and the pumps. What harm can anybody do with my building management system? If you took that thought and approach to it and not understand what it's connected to and what value that poses to someone who's trying to do some damage to your company, to your reputation, these systems they're serious. We talk about it. I use an example. If it was a hospital, if it was healthcare, if it was an operating room, if it was a nuclear plant, these things have got to be managed and secured properly, and I'm sure they are. But it's making people aware that without the right policies and processes in place and the right tools.
But even in commercial buildings, if you build a 100-storey residential block or a 50-storey office block that's all tenanted out, and someone goes in because and just hacks into it and just turns off all the services, or decides, I'm actually going to turn the generators on at the same time, thinking, bang, there goes it.
It's immediate loss of revenue, loss of facilities. People, it is, and you say, and the problem is particularly for a manufacturer, I see is it's the scandal associated as well. If we let partners install our systems and they don't follow the same processing procedures we do, yeah, it's the company that's got the system in that the article goes out, hey, so and so was hacked. Oh, and by the way, it was a Schneider product, and we look bad. Because it then looks bad on us too. So we've got a lot of work to do as well in terms of managing, like I say, through supply chain partners, our own engineers and staff, really got to build a great awareness about this and make people understand. It's not just the customer that's going to have the pain, it's us as well.
Any more questions? Well, thank you very much, Alex, for